Hey guys, sorry I'm not there to work on this with you in class. Had a family emergency and had to leave town for a little bit. But hopefully this can help you get through some of this if you're stuck. Let's start with number 1. So what's the slope of the line? Remember, slope of a line is just how steep it is. Slope is m, and we take the difference of the y's minus the difference of the x's. We call this rise over run. And every line is, or every point is x comma y. And this is the first point, so we call it y1, x1, y1, and this is the second point, x2, y2. So we're going to go y2 is negative 7 minus y1 is negative 4, and x2 is 3 minus x1. Oops, not x1. I meant to say that x1 is 2. So we're going to go ahead and simplify this. We know minus the negatives add the opposite, so we end up with negative 3 all over 1. So my slope is negative 3, and that's all we're looking for. To write an equation of the simplified slope intercept form, remember that slope intercept form is y equals mx plus b, where y is alone. Remember that m is your slope, b is your y intercept. So to find the line between these 2 points, we first need to find the slope. y2 minus y1 over x2 minus x1. Simplify, add the opposite, 5 on top. Negative 3 plus a negative 2 is negative 5. Simplifies to negative 1, that's my slope. I don't know what the y-intercept is, but for any line that goes between these 2 points, I'm going to write an equation where y equals mx plus b. Instead of m, I can use this negative 1 x plus b. But the line is going to go through each of these points where x comma y is a solution, meaning when I put in 2, I'm going to get out negative 1, or when I put in 3, I'm going to get out negative 4. So we're going to try that. So I know for my equation, when I put in x is 2, so negative 1 times 2 plus whatever the y-intercept is, it should equal negative 1 here. So we go negative 1 equals negative 1 times 2 is negative 2 plus b. Solve for b, add the 2, and I get b equals 1. So therefore y equals m, which is negative 1, x plus b, which is really simplified to y equals negative x plus 1 is my line. Number 3 is the relation of function. Remember that a function will pass the vertical line test, which also means that there are no repeating x values. So if I look here, there's 2, 5, 9, 6, and 2. These 2 x's are repeating, so therefore this is not a function. If I look at this one over here, find each aspect of the graph. So looking at this graph, the domain, remember that domain is talking about the x values that it can be. So if I were to think about kind of this like extreme point over here, I know it's going all the way to the left from negative infinity and all the way down to negative infinity, if you were to call that a point. And then this point over here, we're going all the way to the right, positive infinity, all the way down to negative infinity. So this is one of the strategies we can use, is like kind of taking these important points and labeling them. So like I know this is negative 2 comma 2, this one is positive 2 comma 2, this one is 0 0. But for my domain, I want to know, okay, what's my least value? Well, I know for my least value, I'm going to the left, negative infinity, and for my biggest value, I'm going to the right, positive infinity. So I'm going to say my domain is negative infinity to infinity. And for my range, I know it's my y values. So my y values from all the way down, both of these here tell me that my y values go from negative infinity, that's my lowest value of y, and as I go up on the y-axis, I see these 2 points have the same height. I see their values, their maximum values are 2. So that tells me the biggest value I can go on the range is 2, and I use a bracket because it can include it. Now let's talk about those relative maximums or minimums. Remember, a maximum is anything that looks like a peak of a mountain, right? It looks something like this where we have a maximum. I see that we have 2 of them here. Here's 1 and 2. So remember, if those are my points where we have maximums -2, 2, and 2, 2, we say the maximum is the y value, which is 2, at x equals whatever the x value is at that point. We also have another maximum at 2 when x equals +2. So there's 2 maximums. Do we have any relative minimums? So we see anytime we have like a valley, right, we see that there's going to be a minimum here. So in that case, we have a minimum at the point 0, 0. So we say it has a relative minimum of 0 when or at x equals 0. So that's how we state the maximum and minimum. We say that the max or minimum value is the y value at x equals whatever the x value is. Now let's talk about the increasing, decreasing, and constant. I'm going to highlight these. So increasing, I'm going to highlight this in green. I know I always go from least to greatest or left to right, so I know from here to here I'm increasing. And then after that, I'm going to start decreasing. And then after that decreasing time, I'm going to start increasing again. And then we start decreasing again. So if I'm going to kind of break down where we're increasing, remember that when we're talking about the interval that we're talking about is the interval of what x inputs do we see increasing. So I know my interval for here when I start to go from left to right, so I'm increasing from when x is negative infinity all the way to when x is -2. So we're going to say it increases from negative infinity to -2. We always use a parentheses on increasing because at this point it's actually neither increasing or decreasing, it's changing value, so we don't include it. And then the next time I see increasing, we're starting from 0 when x is 0 all the way up to when x is 2. So I'm going to say also from 0 to 2. Now let's talk about decreasing. So when we're decreasing on our graph, we're going from when x is -2 all the way down to when x is 0. So we're going to say from -2 to 0. And then we're going to start again from 2, x is 2, down to where x equals 0. Or not 0, positive infinity. And there's no constant part because it doesn't go completely flat anywhere. So we say that there is no value where there's a constant. Okay. For part B, you just want to sketch the graph on your graphing calculator and then sketch it on here, and it's going to look like this. Okay. Then you're going to analyze that graph just like that. You can look at the key to check your answer. If I'm describing a parent function, so remember a parent function, we're going to look for the variable and the power. So my parent function is a quadratic where y equals x squared. And because of that, it helps me to see easier where we have some changes from that parent function. So I see there's a change here, I see that there's a change here, and I see that there's a change here. So we're going to label each and every one of those changes. Remember, every description of a transformation is described 3 ways. So number 1 is either a vertical or horizontal. Number 2, it's either a translation. Remember, a translation was when we're adding or subtracting a dilation where we're multiplying by a number or a fraction. And the last one is when we're multiplying, it's a reflection, and that's when we're multiplying by a negative, okay? So again, translation is when we see addition, subtraction. Dilation is when we're multiplying by some number, and a reflection is when we multiply by a negative, okay? And then step 3 is how are we moving? So if it's a translation, is it moving up, down, left, or right? If it's a dilation, what's its factor? So by a factor of something. Or if it's a reflection, is it moving over the x-axis or over the y-axis? So we're going to answer all 3 of those questions for each of these changes. So let's talk about this one first. Remember, outside of the parentheses means it's vertical. It's multiplying by a negative, so we know it's a reflection. And if it's a vertical reflection, it's moving over the x-axis. Because in order to flip up and down, it has to go over that horizontal x-axis. Let's talk about this one. It's inside the parentheses, which tells me it's a horizontal transformation. It's adding and subtracting, so it's a translation or a shift. And because it's inside the parentheses, it's horizontal, which means we don't trust it. We also call this funky town to help us remember. So -2 isn't moving to the left, it's actually moving to the right by 2. And my last one here, outside the parentheses is a vertical. This is adding and subtracting, so it's a translation or a shift. And this one, because it's vertical, we trust the number, so it's going -8, which means we're going down 8. Okay, let's look at this one. So here we're talking about different operations with functions. So here's f of x, and here is g of x. Okay, whoops. So what is f plus g of x? So we break that up into this notation of f of x plus g of x. So f of x is 2x plus 1, and we're adding it to g of x, which is x squared, and we're going to combine like terms. So we've got x squared plus 2x plus 1, no like terms, write it in descending order. So what about f minus g of x? So remember, that's going to be f of x minus g of x. So in this case, f of x, remember we just said was 2x plus 1. We're going to subtract g of x, which is x squared. Don't forget that negative applies to every part of anything that goes after it. So if x squared had multiple parts to it, we would distribute it through. We can go ahead and subtract this now. I know, 2x plus 1 minus x squared. Write this in descending order, which is negative x squared plus 2x plus 1. So what is f g of x? Remember, that's f of x times g of x. So f of x is 2x plus 1, and we're going to multiply it by x squared. So just like when we're multiplying, we distribute each part into each part of the other multiplier. So 2x times x squared plus 1 times x squared. We end up with 2x cubed plus x squared. That's in descending order. Lastly, or not lastly, but now we have f of x divided by g of x. We know that f of x is really just 2x plus 1. And we're going to divide it by x squared, which is g of x. Now, there's no like terms here. I can't simplify, but we do need to clear up one little thing. There's one situation where we can't have a denominator of 0. So if x was 0, that would make the denominator 0. So we say x cannot equal to 0. So anytime we have a value that could potentially make this undefined, we want to make sure that we say, hey, this will work as long as we don't have these specific values. Okay, let's do a composition. F of g of x looks like f of g of x, which means that g of x is going to replace anytime we write x in the f function. So we know f is really 2x plus 1, but instead of x, we replace it with g of x. So what is g of x? Remember, it's x squared. So we know this is going to be 2 of 2 times x squared plus 1. Simplify this, we get 2x squared plus 1. That's our composition. And now we're going to find our inverse. Remember, the first step of finding an inverse is if f of x is 2x plus 1, we're going to replace f of x with y to start. And now we're going to use our inverse steps. Inverse step 1 is to swap the x and y. So we're going to rewrite this as x equals 2y plus 1. Then we're going to get y alone, or solve for y, isolate y, minus the 1 over. We get x minus 1 equals 2y. Divide the 2. We get y equals x minus 1 over 2. And then our last step is we're going to rewrite using the inverse notation. And instead of y isn't the same thing here. We're actually finding the inverse of y. In that case, it's the inverse of f of x that we were looking for. Instead of y, we write inverse f of x equals x minus 1 over 2. Okay? Those are all the same steps. You can check those answers in the key. So let's talk about whether it's even, odd, or neither. If you remember, the test for an even or odd or neither function is we plug in and evaluate f of negative x. If f of negative x equals f of x, it's original, then it's an even function. If it equals negative times all of f of x, then we call that an odd. And if it's neither f of x or opposite of f of x, we call that neither. So those are my options. Okay, so let's look at this. So if I have f of x equals x squared plus 2x plus 2, let's find what f of negative x is, which means every time I see x, I'm going to replace it with negative x. So I'm going to plug in negative x here and negative x here. And now I'm just going to evaluate. Negative x squared means I take negative x times negative x is positive x squared. Plus 2 times negative x gives me negative 2x. And then we bring down the plus 2. Now we compare. Let's look at this compared to our original function. So what do these do? So we see here x squared and x squared are the same, okay? But we see here that 2x and negative 2x are opposites. So right here we know, okay, these are not going to be exactly the same, so it's not even, but we know they're also not exactly opposite. Not all of them are opposite, so it's not odd. So we say this is neither even or odd. Okay, so looking at the graph, is this a function? How do we know? So remember, if we know if it's a function by if it passes the vertical line test. So does it pass the vertical line test? Let's see. If I can draw a vertical line anywhere, it will pass in all of these pass. So it does pass the vertical line test, therefore, yes, it is a function because it passes the vertical line test. Is this 1-to-1? So let's see. 1-to-1 means it has to pass the horizontal line test. So does it pass the horizontal line test? Let's see. I can draw a horizontal line anywhere as long as it only passes one time. We are good to go, and we see that here. It does pass, so therefore, yes, it is 1-to-1 because it passes the horizontal line test. And then finally, does it have an inverse? So does it have an inverse? The question is, well, an inverse has to be 1-to-1 in order for it to have an inverse. Is this 1-to-1? Well, yeah, it is 1-to-1. So therefore, we say it has an inverse because it is 1, 2, 1. Okay, so that walks you through how to do all the types of the questions on your test. I'm going to go ahead and finish this on the key so you can check your answers. Please email me and let me know if you have any other questions. Test will be on Friday.